And I am live. Yep. And yes, today is 20th of September 2025, Saturday. And let's just do, there are only a few questions left in the dynamic programming section here in CSES. Yesterday, we only did two questions, and one of them, uh, counting towers, this one took like 3 hours or something. Yeah, but we were able to solve this at the end, which is kind of cool and pretty good. And for now, which is the easiest one, this one, projects. Ah, yeah. And let me come straight. I did read the problem statement yesterday, and I had time to think about this since yesterday, and this is going to be a bit easier because there was a contest in which there was the question number C was very similar to this, and it was a recent contest. Yeah, the third question in that contest was very similar to this one. And in that question, we were looking for blocks, and it was also supposed to be done using dynamic programming. And yeah, but I was not able to do it during the contest, but now I can get some help here because of that prior knowledge. Okay, shit, this theme does not really look good. Like literally, this kind of looks bad. This one IR black. This is the one I was using till now. Let me just change to that. Config and go see IR black. I guess infrared black. And now if I shit, I do not remember how to reload the config file in Ghost. There is supposed to be an option. Okay, let's see how to reload config file in Ghost. I guess Control R or something like that. Control Shift comma, like Command Shift comma. Okay, cool. This is fine now. Yeah, this is the one that I like. And Tmux ls, yep, everything is working. Attached CSES CDDP LSN, yep. Some updates in lazy, and not in lazy, in some of the plugins. Loop LSP, I don't even use it very often. But anyways, thank you. CDDP. And now this is the question for the day. And let's just begin with this. And yeah, stream is going pretty cool. So there are n projects you can attend. For each project, you know its starting and ending dates and the current amount of money you would get as a reward. You can only attend one project during a day. What is the maximum amount of money you can earn? During a day, I can only attend to one project. So wait, you know, it's starting and ending days and the amount of money you would get as a reward. You can only attend one project during a day. What is the maximum amount of money you can earn from the start to finish? In the first line, n, the number of projects. After this, there are n lines, each with AI, BI, and PI, the starting day, ending date, and the reward. Print one integer, which will be the maximum money that I can earn. That is kind of neat. So these are the starting dates on the left, and on the right, these are the ending dates. And if we put a line, which is a very straight line, and days start from 0, and it is going to take time to write them like this. So 1, 2, 3, the maximum date is 8, 4, 5, 6, 7, 8 is the maximum date. And how many projects we have? 4. projects. One is spanning from 2 to 4, another spanning from 3 to 6, and then another spanning from 6 to 8, 6 to 8, and then another from 5 to 7. 5 to 7, and I guess these are inclusive dates, and these are the prices: 4, 6, 2, and 3. And my idea is to go through these projects in ascending order of their starting dates. Therefore, if I rearrange these, well, in the ascending order of their ending dates, and these are already in the ascending order of their ending dates, and I will also have a DP table where I will say if I stop completing these projects at some certain day, then what is the maximum amount of money that I can have. So here 0 because there are no projects that end here, and then here also 0 because there are no projects I could have completed by day 1, and by day 2 the best thing is 0, and by day 3 again 0 because no projects have ended at this point. But at day 4, if I do choose to go with this project, which starts from 2 and ends at 2, this one, I will be able to earn 4 units of money. So I can put 4 here, and then at day 5 there is no project ending at this point, so again the maximum is 4. And at day 6 I have a choice to give my time and do this project which starts from day 3 and ends at day 6. But if I do that, I will have to take the best project at day 2 because I will be starting this project from day 3. So I would have to take the best value up till then and add that to this value, which I will get as a consequence of going with this green project, this thing. Or if I don't complete this green project, in that case the answer would still be 4. And here we are taking the maximum, which is 6, so we will go with the green project, and this is cool. Now on day 7 this brown project is ending, and now I again have a choice to go with this brown project or not. And if I do not go with this brown project, the maximum amount is going to be still 6. But if I do go with this, then I will have to see what was the best value at day 4 because I have to start this brown project from day 5. So at day 4 the best value was 4, plus I will be adding the value for this brown project, which is 2. 4 plus 2, so whatever is the maximum, they are the same. I can just go with 6. Cool. And then for 8th project, this project which ends at 8, if I do not go with this, then I will get just 6, which was the value for the previous day. But if I do go with this, I will have to take the maximum value at day 5 because at day 6 I have to start doing this project, and the best value at day 5 was 4. And what is the value that I get if I do go with this, which is 3, and this is 7, so we will go with 7, and the answer should be 7. Moment of truth, 7. Okay, yes, we can just now implement this simple algorithm now. And n c n, and what are the values are kind of fine, we can handle them in integers. Vector of pairs, yes, vector of pair of integers, let's call it a, size will be n, and yes, size will be n, and pair in empty pair for int I equals 0, I less than n, I plus plus, c in ai, dot first into AI dot dot second and also the values. So for the values, I can have another vector, but that vector would also have to change. So let's use a tuple instead using TP equals tuple of integers. TP 0, 0, 0. I think this might not be the best thing, but yeah, it is whatever it is. And how do you access elements of a tuple? Shit, I literally don't know. How do you access the elements of a tuple? Okay, how do you access the elements of a tuple in C++? Dot get get second in my tuple, second in my tuple. And how do I put? Okay, so to put also I have to use this get symbol, this get syntax. Okay, this does not look very beautiful. Instead of taking the input like this, I could take this in a pair of vector and then sort this thing. Yep. And use iota pair int, but then iota is not really good. Yep, tuple is the way to go, right? Yes, because I need all of these things together. Vector TP a size n and TP initially everything is 0 and Cn. What is the syntax? A dot get standard get 0, get 1, get 2. Okay, let's use that even though it looks bad, really bad. Yes. Cn get 0 AI, yes, and get 1 AI and get 2 bracket AI. Okay, is this thing even compiling? Okay, it is running. That is cool. That is cool. Now I can sort this thing. Sort a dot in, a dot end with a custom function auto x, which is the first tuple. I can write explicitly tp x and tp y, and then sort them on the basis of their ending date. And if they have ending on the same time, okay, if get 1 for x is not equal to get 1 for y, then return get 1 for x lower than get 1 for y. Else, if that is not the case, then sort them on the basis of their starting date. No, 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 that is the only metric. Yes, that is good. That is good enough actually. That is the only thing that we care about. And now we can move forward. Vector long res size is going to be n plus 1. No, size is going to be the maximum ending date. So end mx n as mx end equals maximum of mx end or get 1 AI. And here we can initialize this to equal to 0. Uh, max n plus 1. And every value initially is 0. Now for int I equals 0, I less than n, I less than n, I plus plus. Yes. Now if I go with the current AI, then there's not going to be, okay, res. Huh. Okay, this is kind of in a way funny. 10 power 9. Okay, this is, yeah, shit, this could be problematic because I need to fill everything internally. Hello, how are you? Because here value of AI and BI can go up to 10 power 9, and if I have to fill everything in this array, then this array is going to be at max of size 10 power 9, which is 1 GB. I do not have that much storage, not even 1 GB. This is 1 gigabytes. I would need 4 GB GIB. So there has to be a better approach, and that would be using a map instead of this thing that I'm currently using. And yeah, instead of this, I think using a map would be pretty nice. Map for integer, and the value would be long. Let's call it res. And we are saying res is 0 equals 0 at day 0. This is our base case. Day 0, our answer is 0. Yes, at day 0, our answer is 0. And if we actually, instead of this model, if we use a map, let's see how it goes. Okay, we have a map now, and therefore we will first go to the last end. Initially in our map, we have 0 pointing to 0. And now we are here, and we ask the question, if we do choose this, then we will get a value of 4 plus the best value which was before the 2 point. and before 2 we have only value 0, whose only key that we have is 0, whose value is 0. So best value before 2 was 0. If we do choose this task, this pink task, the value we will get is 4 plus 0, and if we do not choose it, it will be 0, which is the value of the last thing. Initially it is 0. We can say LST equals 0 initially, and here's clearly the maximum is 4, so we go with 4, and we will update the last value to be equal to 4, and also we will put this into our map, and we will say that at 4 at 4 our best value was not 4, yes, was also 4, was also 4. Now we go to the next end point, which is here at position 6. This green task is ending at line 6, and now we have the choice of choosing the last value, which is 4, which would correspond to not doing this green task. But if we do decide to do this green task, we will get 6, and we will have to see before the starting point of 6, which is 3, what was the best value, and before 3 the smallest value that we have is 0, not 4 but 0. 0 is the largest value that is smaller than 3, and its value is 0, so we will get, and here this is the choice, and we will surely go with the third task, and we can say at 6 the value which we have is equal to 6. It is equal to 6, yes. At endpoint 6 our value is equal to 6, and we can also update our last to be equal to 6. Okay, yes, that is cool. And then here with 7, and also this is a monotonously increasing function, which is pretty nice. And then at 7, if we go with this 7 task, if we do not go with it, the value which we will get is 6. But if we do go with it, we will see what is the largest value, that what is the largest key which is smaller than 5, and it is 4. So we will have 4 plus what is the value for this brown task, it is 2. 4 plus 2, and here the thing is like same, so we just do not do anything. Yes, here the value is 6. So the question is, do we update this also? Nah, we don't have to. We don't have to. It is fine as it is. And then we will get to the last thing, which is 8. And if we go with this, if we do not go with this 8 task, we will have the last value, which is 6. And if we do go with this 8 task, this 8th task started at position 6. I think putting that equal value is is it also helpful? No, it is fine. It is fine. We do not have to update it. And yes, here if we do not go with this task which ends at date 8, then we will get a value of 6. But if we do go with it, then we get 3 plus the best value before we started this task. We started this task on day 6. So what was the best value at around day 5? And since we do not have any data about day 5, the largest value that is smaller than 5 is 4. And at that point, we had a value of 4. So this thing, 3 plus 4. And here clearly the maximum is 7. So 7 and LST equals 7 last. And that is the answer. And we can also put this here. And we can say should this not monotonously increasing? Wait, shit, this is not monotonously increasing always, because what if I have a very high value task which ends? What if we get a very, very high value task on this day, and which starts on day 2 and ends on day 10, and let's say the value that we get with it is 100. And if that is the case, we will put 8, not 8 but 2. We will update, let's say, it ends. Okay, it is ending on 8. Okay, yeah, yeah, yeah. We are putting the ending index here. Okay, that is fine. That is fine. We are using the ending index to index. Yes, that is. Hello. If you're done with most of the CSES. Yes, I saw that, and I was trying to do it, and there was knapsack 2. Knapsack 2 is crazy. At coder DP contest tasks. This is the thing. This question knapsack 2. This is crazy. I don't know. This needs some crazy optimization, because look at this. Maximum weight is 10 power 9 and number of items is 100. I thought that the way to do this would be not to go through all the weights. That seems kind of obvious because we cannot go through all the weights. And so we have to reduce the number of weights that we are going through. And we can do that by first calculating it, going through all of these n weights and finding out what are the possible weights that we could have. And instead of using a vector, therefore, whose index is the weight that we are currently at, we should use a map instead, and that would be nice. And yeah, but I guess I messed up in implementing that thing, so that didn't work out. But here, this is also a very similar problem, because we cannot blindly create an array of size 10 power 9. It is going to be bad. So we are selectively going through stuff and using a map instead of a vector. And we will have to see, do we use a unordered map or a normal associative map? Long, initially the value is 0. Now we are currently at some particular thing, and we will update if LST, if last value is smaller than what we get right now. And what we get right now would be the value of this current thing, the value of this current task that we are at, which is the third element in the tuple. So get third element is represented by 2 in the tuple, which is AI, plus what was the best value before that, which is going to be okay. And map is also not okay. Map is something that we will have to use, and we are going through n things, and internally each map lookup is taking log n time. It's time complexity and log n, which is fine, which is very, very manageable when n is 10 power 5 at max. So that is cool. And let's say auto IT is auto iterator would be res dot lower bound. Do we ask for lower bound? Lower bound get 0, which is the starting date, because if yes, lower bound, we will go with lower bound. AI, and yes, then we'll do IT minus minus, go to the previous element, and when we are at the previous element, go to that previous element and get its value. So go to IT dot second. If this is the value that I will get if I do choose decide to do this current task, and LST is the last value, and if the current value is smaller, okay, also long CV, let's say current value will be get to AI plus go to IT dot second LST. If the last value was smaller than the current value, then we will like to update our last value. First of all, last value will be equal to the current value, and also we will like to put this into the map get to get 1, which is the ending point. Ending point is going to be the index, is going to be the key, and with this key the value is going to be LST, which is now current value. Yes, that is cool. And at the end we can see out last value, and last value is going to be the maximum value because it is always increasing. Line 24, map, what is the mistake? Ah, and now IT second has no named second. Yes, shit, I was having some similar problem also yesterday. Go to no, yes, go to this thing and get its second, but this might still give some error, or maybe not, or it might actually return the correct answer. That is cool. Hello, preparing for placements? Not yet. I'm just trying to get better at competitive programming. What is your current rating? It is about 1300, just 1300, but it will get better. Do not worry, it is going to get better. And before submitting this, let's see, could there be any mistakes? Okay, in this tuple, everything is a integer. That is fine. And let's use a macro. Okay, let's use literally use a macro because I do not like this get syntax, right? Yes, G0 x, how do you define a macro? G0x get 0 for x. This is what I want. Can I now use this whenever I am getting 0? Is this going to work? G0 AI. Okay, it is working. It is working. Okay, but yeah, they're just like unnecessary layer of abstraction. Not good. Okay, I think this is correct. And before submitting this, I would like to just delete this whole thing and rewrite it again from scratch because that is what good programmers do using tuple equals using TP equals a tuple of int of 3 integer values. And then a vector of those tuples, we will call them n, and individually TP initialize all of them. Now for int I equals 0, I less than n, I plus plus, get in the current value, which is get 0, ai, get 1, ai, and get the second value in the tuple, ai. And also we would like to keep track of, we would not like to keep track of the maximum value, we do not need it. Now after this we will like to sort the tuple, sort a dot begin and a dot end, and our lambda function is tpx, tpy, and return the maximum value according to the second element in these tuples, which is their ending, which is their ending date for the tasks. Yo, in competitive programming, there is no good programmer, bad programmer. Although I generally comment the previous code, so if I get lost somewhere, I can roll back. Oh, that is pretty nice. I mean, I can also do that here in Vim. We get this thing. Okay, shit. Okay, I messed up. Shit. I messed up. I messed up a little bit. Yeah. Here in Vim, we have this thing on the left. We can use this and go wherever we want in the memory. It is like a GitHub commit kind of thing. And yeah, this works pretty nice. It is called undo tree, which you get in Vim. If you use Vim, that is just the power that you get. And now the data structure, which will have the answers. Long res, initially res 0 equals 0, and lsp long lsp equals 0. Just in case, long. And now we will iterate through the tasks int n, I plus plus, and the last value, we already know the last value, and the current value would, first of all, let's get a iterator to the last element. It would be res dot lower limit for get 0, the starting value for ai, and after it go to the previous element, then long current value would be go to it dot second, the value plus the value which is given to you by this current element, which is going to be the second value in this ai. Now if last is smaller than cv, then last equals cv, and put it into the map res. Index is going to be the second, uh, index is going to be the end date for this current task, which is something like this, and the value is going to be cv. Cout lst. I think I messed up with, how do you write lower limit? How can I mess this thing up? I genuinely do not. Upper limit, lower limit. How do you write upper limit and lower limit? Lower bound, upper bound, lower bound, not limit. Right. I think that is something which can happen from time to time. Okay, this seems correct, and we can use this now. So like fast language matters in contest. Yo. CPP, Java, yo. Mm, submit the file CSES DP. What is the name of CP projects? Okay, moment of truth. Shit. Okay, I thought something might go wrong, but okay, this is good. This is good. This is good. Hmm. And I was able to do this because there was, I do not remember which contest, but a recent contest in which there was a question just like this one, question number C. And yes, this is not contest. This is a contest, not interview. That is nice. It may be this one. There was a contest in which we had a similar question, very, very same. Ultimate value? No, it was something related to blocks. Cake assignment? No. This one or this one? Could be this one. The nether. Shit, might have been the. Uh, yep, I think this is the one. Yep, this is the one. This is the same question. Not same, not exactly the same, but very similar. And why have I not done this? Yes, 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 yes. This is the question. This is the question. And why have I not submitted this one? Okay, let me just do it in a minute. Uh, Contest is 1046. I can just go to the session where I solve contests 1046. Start new vim. I probably have it. Yes. This is the code that I wrote. And is this correct? Yes, this is working. But I didn't submit this somehow. Wait. Mhm. Okay. Anyways, let's read the analysis for this one. Yep. CP3 or CP4 book. What are the future plans for this channel, bro? The future plans for this year, it is just to get really, really good at competitive programming. And then next year, I want to learn a lot of things and do some things in development, create projects, and I will do stream about those projects. Maybe some projects related to gaming, games, writing games, and also web development projects for the next year. And I think that would help me in getting a job in 1300 prime region. Thank you for that. Thank you. That is a huge honor. Uh, Prime region, Michael Paulson. And what is this CP3 or CP4 book? Uh, what is CP3 book? Fair. Competitive programmer, programming 3 book, the lower bound of programming. So what the heck is this? What is this thing? Competitive programmer book. Mm, that is Omega. Stephen Hamill, Mr. Stephen Hallam, retired 2, 3, 4, 5. Shit. Shit, this is a whole thing. Okay, competitive programmer book one PDF. Okay, so this guy has written a series and CP3 is old. So these things are like, you mean book one is the first one that you have to read, and then book two is book is like the next book in the series, is it builds on top of the previous book, or it is just a better version of the previous book? The same thing, but better and like more updated version. Competitive Programming 4, Book 1. The naming scheme is amazing. Book 1 and Book 2. Okay, so right now we have Book 4. No, all are same, but updated versions. Okay, no, same thing. Okay, same thing, but better version. And now we have Competitive Programmer 4, Book 1 and Book 2. Okay, so each version, CP1 has 2 books, and the next one also has 2 books, and they are like better than the last one, I++. That looks good. And okay, that is pretty cool. Wait, that is anti-Larksonen. Why are there 2 things? Okay, edition 1 and edition 2. And let me show you, you can use libgen. I think you know this. Library Genesis, Stephen Hallam. Programming, Stephen Hallam. Yep, book 3, book 4. All of them are available in PDF. Book 4, version 1. Shit, I messed up. Competitive Programming, Stephen Hallam. Book 1, book 1. This is the one. We can just download this, and this is very, very illegal. Do not do this at home. The server is down right now, but yeah, this is something where we can download books from. That is nice. Hello, Loki. I just started coding. I'm in high school. Any recommendations for me? No, only book 4 has a wasted day, like searching what are they? Where are you currently? Ah, Loki. Uh, Prism is trying to help you. He's going to help you. He's very competent. And the analysis for this question. And yes, you can also do like, of course, you can do CSFT. CSFT is amazing if you are just starting out. Bro just left. Uh, if you are still here though, you can do CS50, which is pretty amazing, and the like only thing you need to get started. Yep, I'm from Punjab. He meant as in like what stage of programming you are in. I think that is what you meant by where are you currently. Let money I denote the maximum, and getting back to the analysis, let money I denote the maximum amount of money that can be obtained by attending project I and possibly some other projects before it. We can use the following recurrence. Maximum of, for the ith money, go for j money plus the present money, and if I do choose the ith project, and internally here we are, ai is the starting date, so every bj, that is every ending date that is smaller than the starting date for this ith project, we are going there, and j is lower than equal to n. Okay, and add the current value and find the maximum. Okay, since n can be very large, we need an efficient way to find the j project with the greatest money j ending before project I starts. Sorting the projects by either the starting or the end dates is not sufficient because the money value needs to be computed on the basis of the starting date of the project, but the value only becomes available to other projects after the end date. After the end date, yes. Okay, we can use a sweep line approach set. where each project is split into two events, one at the start date and one at the end date. The value money I is computed at time I according AI according to maximum value among projects that have already ended. The current maximum value is updated once the project ends at BI. Yes, BI is the ending date for the current project. Okay, to ensure that projects ending on a certain date do not influence projects starting at the same date, we start events sorted before end events if they occur on the same date. To ensure that projects ending on a certain date do not influence projects starting at the same date, start events are sorted before end events. Start events are sorted before end events if they occur on the same date. The time complexity is n log n because of the sort performed. Okay, they are using some algorithm, time, project, and is end. It is a struct, and they have a Boolean operator overload on this thing. Depending on time, this takes in other event. They take in the time for the other event. If they are similar, then return true. If the current one is if the current one has ended and not if it hasn't ended. Okay, they are using something called sweep line algorithm. I don't know what that is. Sweep line algorithm, but I was able to do this in some other way, I guess. Competitive Programmer's Handbook, there was a sweep line algorithm there. Sweep line algorithms, shit, something like this. I guess I don't need this just right now. Convex hull problem. Yes, shit. Okay, I do not need this right now. Right now, I just have to work on dynamic programming, and I got this right, so that is cool. Now we can move on to the next dynamic programming question, and now there are 1, 2, 3, 4, 5, 6, and 6 left, and one is somehow wrong. I will look it up how it is wrong. And now what is the easiest one? Easiest one is elevator rides, and only 11,000 people have been able to solve it. Let's see how this goes. Thinking about reading a book on computer science and also thinking about C. Shit, bro's thinking in C. Thinking in C, by the way, is a book. Yep, that is a very nice philosophy. Learn stuff when you need it, right? Now this problem, okay. Okay, and my goal would be to complete at least 2 more problems for the day. And the remaining problems are hard. Let's see. And it has only been 1 hour, so and if I stream for 2.5 more hours, 2 problems should be nice. This is the next one. There are n people who want to get to the top of a building which has only one elevator. You know the weight of each person and the maximum allowed weight in the elevator. What is the minimum number of elevator rides? Okay, so I need to put in maximum number of people, and this is very similar to the knapsack problem. Here we can take value for each person equal, value for every person is equal, and yes, value for each person is equal, and their weight is just their weight, and the capacity of the elevator is the capacity of our knapsack. And whenever we find the best solution, at a certain point, we remove all those people from our array in which we are storing that data. There are just 20 people at max. Yes, we can just remove them. We can use a map or anything, does not matter. And then we do it again, maybe a couple of times, at maximum 20 times. Let's say I just take one person in each elevator lift, and whatever number of times we are doing this whole thing, that would be our answer. That seems nice. So 4 is the number of people we have, and 10 is supposedly the weight of each person. And why is n equal to 20? Is there some optimization that is needed? Wi can be pretty big, so we cannot. Shit. This is difficult because of the same reason that this knapsack 2 is difficult. And I think if we can do this one, we will be able to do this one, because here also the limit, the problem is this. The maximum weight is 10 power 9. That is the problem. Yes, these are very similar problems, and if we can solve one, we will be able to solve two. They are NP complete. Okay, let's do them. And wait, I didn't notice. You also use Vim. That is pretty amazing. Where you code and solve problem that Pro is currently doing. Where you code that problem. Oh, okay, you are talking to him. How much quality hours you can put in? Yes, put in quality hours. Don't just sit. Right. Being active and in the moment, I guess. N and X. X can be very big. Let's call it W. C in N. C N N, yes. And W, and then let's take in the values. Vector integer will suffice, a size n for int reference x, and yes, we can take in x. But now, since, okay, this is what I'm thinking about. Since the maximum weight is very, very big, 10 power 9, and if we ask, can we achieve this weight? I mean, 10 power 9, that is a very big thing. And generally, what we do is we go from 0 to weight W, and for each weight we ask the question, can we, what is the best value we can get at this weight? But that is something we cannot do here, because the space of weights is very big and inefficient. So I think the best thing would be to, the minimum weight is, the minimum weight that we can get is going to be the uh, if Wi is the weight for the ith item, it is going to be the minimum Wi, minimum Wi. So we will have which is, I think, going to be non-zero. We will not have a person with a weight of 0, which is going to be non-zero. That will be our lower limit, L, and the maximum weight that we can achieve is going to be summation of all the weights. That is going to be maximum, and all the weights that we could achieve are going to be between these two things, lowest and the maximum inclusive, and we will run one loop. But and we somehow have to find all the weights which are between these two values which are available, right? Which we can somehow get to. And instead of asking here what is the best value which we can get at any arbitrary weight beginning from 0 till the maximum capacity of the elevator, we should be asking this question for each weight that is attainable, right? There is no point in asking this question, asking the best value for weights which we are not going to find. So the best thing would be to find the weights that are possible, which is very similar to a question that we have already done. Possible numbers or money sums. I think money sums is the question. Yep, money sums is the question. You have n coins. Your task is to find all the money sums you can create using these coins. Yes. So money sum, something like this. And the algorithm that I used in this was very inefficient. I was using sets and things. But what were the constraints? N, yes, see, xi here is 1000 and here the maximum value for a weight is going to be 10 power 9. But the advantage that we have here is 20. N is only 20. Here n was 100, 5 times lower. Almost a magnitude lower than this one. Is it, how is it going to be? Intuition building. No, no, let me get this one. Let me get this one. Thank you for the initiative, but let me get this one. I'll get it. I'll get it. And yes, what I think is just to find the weights which are possible and ask this question for only the weights which are possible to get. But then this would be similar to solving two problems, and that is not bad. Okay, let's do this. Okay, text document definition. Yeah. Print one integer the maximum number of writes. Um, I mean, a greedy algorithm could also work here, right? No, maybe not. Wait, shit. I think I was making over engineering this. Since we know that 10 is the maximum thing, and I can say for this one, we can start with this, and I say current value is 0. Current weight is straight. This is, we can do the same thing that we did in the question that we just solved, right? Projects. We can use a map. Yes, we can use a map and we can initialize 0 has a value of 0. When at weight 0, the best thing we could have done was 0. Was using this. Yes, now when I am considering this weight 4, my question would be to use this or not to use this person with weight equal to 4. Yes, and LST, our last value, will be equal to 0 initially, and we are looking for maximum LST last value. Or if I do use this, first of all, I will see, can I use this? Yes, I can, because if I do use this, yes, if I do use this, this thing is lower than 10, so I can use this. And if yes, always I can use the current weight, always. And if I do use this, what would be the best value at weight 6, which is 10 minus 4? What would be the best value? Because only weight 6 is something that is remaining, and lower than 6, the only value we have is 0. So 0, and the value that we get, the only answer for the weight we have is 0, and the value that we get is 1. And last is just 0. Last is 0 here, so 1 is better, so we will go with 1, and we will update these values. So we will update last to be equal to 1, since we have this person here, and we will also put the best value at not weight 0, at weight 4. Do we put it with weight 4? I think we do. No. Yes, where do we put this? That is a nice question. What should be the key for this value? It's nice. All right. Value is value, and the key, why is this hard to think about? The key should be 4. No, the key should be 4, because not exactly 4, but this key that I had earlier plus this current key, and the earlier key was 0. The thing is that this is supposed to be a two-dimensional array, right? Weights on one dimension, and the number of things that we are using on another dimension, and somehow I've collapsed this into a one-dimensional problem. Not one-dimensional, this is actually two-dimensional, because when we are searching things up in the vector, yeah, in the binary search tree, it is one dimension for that. So when I use something for weight I, which weight is it affecting? It is affecting, it is the best value for the weight with which we are using this weight. Yes. Yes, 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 yes. And here we will put 1. Then we move on to the next weight, which is 8, and currently the last value is 1, and the next value is going to be, since I have a weight of 2, I have a weight of 8, and my total weight is, the total capacity is 8. I need the best value at 2, and the best value at any number which is equal, which is lower than 2, lower than or equal to 2 is 0. So 0 plus the value which we get as a consequence of choosing this person at 8 is 1. And is last smaller than this value? No, they are the same, so we do not do anything. And yes, we do not do anything, right? Yes. Yes, we do not do anything. I think we do not have to do anything. And then we move on to this next person, 6. And the last value is 1. And the new value would be 1 plus the best value at 4. And the best value at 4 is 1. So 1 plus 1. And last is now smaller than 1 plus 1, 2. So we will update this value. And this thing, the new thing is going to be the value on which we are adding this 6. So the value on which the weight with which we are adding this 6 weight is 4, and also this 6 weight. So 10, the new key is going to be 10 gives the best value of 2. Yes, 10 gives the best value of 2. Yes, and then we move on to the next element, and also last is going to be 2. Then we move on to the next element, which is 1, and last is 2, and the next best value we will get is 1 plus the best value at 9. Best value at 9 is 6. Hmm, I didn't add 8, key 8 having a value of 1, because we would like to have the smallest index. Should this seems like the logarithmic approach for the longest increasing subsequence, but a bit different. 1 plus 1. Shit. We also need to know which elements we are choosing, because if we are going to remove these elements later, then we will have to know them. Yo, just friends having a nice chatting. That is nice. Yes, we will have to know all the elements which we are removing to remove them. But if I use 1 and 4, I am getting a value of 2, but I would also like to change the weight, because 8 and 6. Shit, so this is not a knapsack problem, because answer to the first thing also depends, also has to, yeah. If multiple answers have the same value here, I could choose 4 and 6 for the same value, or 8 and 1 for the same value, or 1 and 6 for the same value, or 1 and 4 for the same value. I would like to choose something with the maximum weight. Yes. Shit, I'm messing this up. What were the four steps for dynamic programming? Define the optimal solution, and the second was define how to find optimal solution given solution given optimal solutions to sub problems. And then the third is find the optimal solution. Find the optimal solution. And in this step, define how to recursively find optimal solution to a given optimal problem. Mhm. Define the optimal solution. How would the optimal solution in this example particularly, optimal solution would be 4 plus 6 and in one case, and then 1 plus 8 in the other right of the elevator. The main problem is to just group these numbers, group some given numbers in a box of some size, so that we need the minimum number of boxes. Here, the size of each box is 10, and these are the numbers, and this is the best way to arrange them. Now, if this is something that we have, what would how is this like? If I remove one box, then I am removing at least one number or an integer amount of numbers. And if I remove a number, no, define the optimal solution. Yes. Bruh. X or LinkedIn, or else maybe the accounts on at least X, cause real software and building stuff happens there. Right? I use X for memes. Yes, but X is pretty cool. I haven't posted stuff there. Hmm. I think we can connect with CEOs of companies with on X, not maybe with not with Elon Musk, but yeah, people having their startup, and we can show them what we have done, and they will, if they are interested, they will DM and they will reply, and we can connect with them and take it up from there. That is nice, kind of. But I think before doing that, we need to have some really nice bases and not like this, creating a few pretty good projects and then approaching someone when you have something to show. That is pretty cool. 4 plus 6, 10, 1 plus 8 is 9. If I had another item whose weight was 2, if I have another person or no, another number with a weight of 2, I would have to add it in another box because there wouldn't be any other way, right? There wouldn't be any other way. Hmm. Okay. Okay. Uh, 4, 6, 1, 8. When I see this, I ask myself, okay, let's go to the second step. How to recursively define the thing. When I let's say I haven't added this 8th, is this person with the weight of 8, this person with a weight of 8, then the best answer was 2, and not just 2, this 2. I can have a matrix with a matrix, yes, a matrix with 0, 1, 2, 3, in total maximum 20 rows, and the index for the last one would be 19, and I will say how many people are there in the first one, how many people are there in the second row, how many people are there in the third box, and like this. And the goal is to just arrange them in a better representation, not accurate one, but a better one visually would be just this one that we are using right now. And we have 4, 6, 1, 8 things. 8 things. And yes, we have these empty boxes whose weight is, whose like capacity is 10. Now, when I see this, I know that I have to put this in some box, but which box? And here initially, I can put this one here in this box, and no problem, because I have to do this, right? And when I see 6, I put this in this. These are all the boxes that are available, and my task would be to uh, see if I can fit this in the boxes that I am already using, and here the boxes that I'm already using, it has a weight of 8, it has a spare weight of 6, and I can easily put this element here, and then I go to 1 and I see the boxes that I'm already using, the spare weights, the total spare weight that they have is 0. So I know for a fact that I must, and 0 is smaller than the weight that I need. So even if I were to rearrange the members in the available box, I would need, I couldn't create a space of size 1 in any of the boxes. So I will have to use another box. Yep. And then 8. Here the total spare weight is 9. And I can easily put 8 into one of them, and oh shit. The example is not big enough to see edge cases. Let's say we begin with spare weight, with some spare weight. Yes, we will begin with some spare weight. Initially, it is 0. And whenever I see an element, I will compare the spare weight with 4, with the current element. And I see that the spare weight is 0. And spare weight is the total spare weight in all the boxes that I have left. Right? Initially, it is 0. And if it is 0 or lower in any way, lower than this current weight, then there is no way in which I can rearrange all the weights in the existing boxes which are in use, so that to have a spare weight equal to 4, because the total spare weight is lower than the weight that I need. Therefore, I will create a new box. And when I do that, so this one is then used, and visually I will create a new box, and the spare weight will be updated by the maximum weight minus Wi. We will add this amount to the spare weight, which is going to be 6. So 6 is the new spare weight that we have. And let's say we go to 8, right? We are rearranging the question. And our new question is 8, 2, not 2, let's say 7. Yes, we will have to use 3 boxes for this. And let's say 2. That is a nice number. Let's say 2 after, because we can put it here and put it here. And then let's say 6. That is nice. That is pretty nice. Okay. So now the spare weight is 6 and the weight that we need is 8, which is greater than the spare weight. So we add another box. Now we have 2 boxes. Okay, we will also have a count for box. Now we have 2 boxes, and our new spare weight is going to be initial spare weight plus W minus the current weight, and this is going to be 6 plus 2, that is 8. So we can remove this, and the new weight is 8, and the number of boxes is now 2. Seems nice, right? Instead of useful, just placebo. It is useful. It is useful. It is more than just placebo. Makes mouse useless. That's it. Yeah, we're pretty fast on the keyboard. And shit, you also use Vim, which is pretty nice. That is pretty cool. I use Vim, by the way. Yeah, Vim is nice. And shit, Vim is also uh yeah, Vim. That is a nice thing. We use Vim, by the way. And next we go to this element and we compare its weight with the spare weight. And there is a possibility that we could be able to have 8, right? There is a possibility that we could arrange the existing items in a way so that to create a space of 2, to put 2 there. And how do we check for that possibility? And that would be the only thing that we need. And we know that we have only used elements like this. What would be the sub problem that this thing exists on, depends upon? This does seem a two-dimensional problem. It is even hard to just describe what the subproblem is. Subproblem size, spare weight is 8. So I know that in total there is a space of 8. And now the question is, can I arrange these elements in such a way? Wait, shit, yes. Can I arrange these elements that I have been through in such a way as to get a sum of total weight minus Wi? At maximum, this is the sum. Some sum that is lower than this. Can I get something like this? And if I can, then I can put this thing currently in some place, I don't know where, but at in some place, and the spare weight would become 6. And then when I am here at position 6, my question would be, can I use some of these items in such a way so that I get a weight that is equal to or smaller than 4? But shit, even if I can, I'm not guaranteed to get all the other remaining items packed inside in the remaining boxes. Yes. Ah, shit. It is dangerous. Do not use it at home. Bye, bro. Okay, bye. He's like E and home and are not working properly. Shit, bro broke his keyboard. He typed too much. Okay, what even are the decisions? The choice that I have is either to increase this or to not increase these. It feels like this could be done using greedy algorithm. Using a greedy algorithm where I keep track of all the spare weights in all the boxes, and let's say it was 6 when I put this item here, and it would be 2 for the second box, the box in which I put it 8, and then I am at 2. And I see, can I put this? What is the smallest box which has a spare weight of 2 where I can put this and this, and then if I do that, then the spare weight for this box is going to be changed and it will become 0. And when I'm here, I see what is the lower bound for this, and it is going to be 6. This is like a set. Let's use this greedy approach. Set of integers is what we are going to have. Yes, and let's call it S. And initially there is going to be just one box with a spare capacity of with the spare capacity of W, S dot insert W for int I equals 0, I less than n, I plus plus. Now S dot lower bound AI, and if auto IT equals the lower bound for this thing, if IT is not equal to S dot, and if we do have some place where we can fit this current box, then we will put it there. If this is not equal to end, then S dot insert go to IT plus minus AI, this current value, and this will be updated. Yes, and S dot erase IT, update the value in a sense. And else, if that is not the case, then S dot insert W minus the spare weight AI, and again C out S dot size. It is working here, but it is working here, but I'm not very sure if it is going to work here. And I cannot even also, I cannot think of a edge case where this might not work. Let's see, elevator rights. Choose elevator rights. E begins with the E. What is it? Am I in the wrong place? Yes, I am in the wrong place. Okay, shit. This 3, 2, 4, 5. Okay, now I am at the right place. My bad. Yo, he's gone. He's like not here. Yeah, he had to leave. Start Vim. In N, C in N, take in N, and also the weight. Shit, my bad. Complete total weight. And internally for vector int a size is going to be I, for in reference X and A, C in X, and internally we will initialize that set S and S dot insert W, and for each element I0, I less than Ni plus plus. For this element, auto iterator equals S dot lower bound for this current element's weight, and if IT is not equal to S dot end, if that is not equal to S dot end, then S dot insert a new element, which is going to be go to IT minus AI, which is going to be the new capacity, and we can remove this IT, which is these two lines are very similar to updating the value of the box in which we are putting this current value. And else, if that is not the case, we will have to create a new box or elevator ride, you could think of. And that would be like insert the spare capacity for this is going to be AI. And we are only doing this when we cannot put anything in the boxes that have been. And I'm trying to think of a edge case where this might fail. And after that is done, just see out as dot size. Okay, let's see if this works or maybe not. This is going to rule, and let's see. Edit distance, nope. Elevator rides. I think this is probably going to be wrong because of the fact that this is a dynamic programming question and I'm using greedy. Yes. Okay, what are the edge cases? I said 5, but could have been 4. I said 5, could have been 4. Let's go with this. Okay, but before we start doing that, let me go to the washroom and I'll be right back in a minute. Right back. Yep. Shit. I'm extremely sorry for that. Shit. Ready for the contest? Yes, amazing contest. Today is going to be a contest. And shit, that was very stupid. That was actually very stupid. Shit. That is actually retarded behavior. But now it is fine. Wait, is my camera? Yes, camera is fine. Wait, what is that thing? Hello, good afternoon. And today is a contest, and it is going to be pretty cool. And the question that we are trying to solve right now is this one: elevator rides in CSES. And I have already made a wrong submission. And but now I think I got this right. And only a simple, it's not simple, but thing is learning. Oh, today is also a ABC. Yes, ABC at Coders Beginner Contest. That is cool. And Eric, how's everything going with you? All the, if this is a DP question, all the preparation for your next month ICPC contest. This one. We will get 3 hours. And these are the people who did all of this at school. And there is also a coconut testing. There is also a newbie player who is like one of them. And that is pretty cool. You just pick up your friends. That is cool. Okay, in this, now we go. Too much ICBC prep. Yes, you I guess get exhausted. Computational geometry is hands on down the worst topic. Shit. Yes, are you on Code Forces? Computational geometry. Wait, and can you share some resources for geometry? Because my geometry is very bad. Computational geometry is very bad. I would also like to work on it. Can you share some resources, a book or something? And the only geometry resource I know of is this section. I think there is a section on geometry. Yes, this one. That is the only thing. Complex numbers, point and lines, polygon area. That is the only resource that I have in on geometry. Nothing else. And this thing. So first of all, when we have this, we will create a map of integer to integer. Mhm. The maximum number of people we could have, and MP. And we need to initialize this thing. No, we don't need to initialize. We don't need to initialize. For int x in p w, for auto x in possible weights. Nah, I do, but I rarely do contests. Okay, I may use USACO and just problem sets from previous ICBC problems. Okay, global round. Rounds are at 12:03 a.m. So it is hard for me to do them. Yes, that is a very terrible tragedy. Yeah, USACO guide. Resources for competitive programming. Gold, silver, bronze. Uh, uh, that is very fast. But okay, let me first write this thing and confirm my belief that this is going to work. X is the current weight. Shit, but the possible weights are also changing with A. Yes, the possible weights are also changing with A. We can say MP 0 equals 0. We will find the greatest element that is lower than the current X. So auto iterator equals MP dot lower bound, and even if it is equal, do you look for lower bound or upper bound? Upper bound. Because if there is an exact weight like this, we would like to add and update W minus what would the weight be? That is go to X. I think I don't need these brackets. This might mean multiply. No, this is not going to mean multiply. Still, and then IT minus minus, so that I am either at the exact weight or at a lower weight. And then if int LST equals 0, now if last value is smaller than the current value is going to be go to IT plus 1. Can this be negative? Could be. No, what am I even doing? Why am I not doing anything with A? Shit. A is the thing. I think I don't even need possible weights. Why would I need possible weights? The total capacity minus this thing. And this thing is lower, and adding this weight would be a good thing. Then add this weight at which capacity mp dot insert and last will be equal to it plus 1, I think, which is also going to be equal to last plus 1, because there are increments of size 1 only. And mp dot insert, not insert, mp the map, going to be it plus 1. But here, what is going to be the key? The key is going to be the weight that is left, which is I just did this. The weight that is left IT total weight minus total weight minus go to IT plus go to X. And how do I find which weights I did use in the last iteration, because I need to update A and remove elements from A. I'm not going to use this thing. I can remove this. I think I'm on to something. Shit, okay. Things auto delete. That's crazy. Okay. Goes around. Platinum section has some convex hull stuff, which was pretty good. Shit. Convex hull stuff. Find the way to put all of these points into a string. And on convex hull, there is a stuff in CLRS book, which is pretty cool. I haven't read it though. And yeah. Okay, so now this is mostly solved. And the thing is, okay, so whenever we are making a decision, we need to update this thing, and we need to have some extra information. We need to have some extra information here so that I can track what are the weights that I used in the current problem. And how do we do that? What is, whenever we are making this decision, what is something that we can remember? Since here we are iterating through I, we are iterating through I, through A, all the sets, and can uh, I think not. Oh, no. I think something like, I think I will need a map where one is the first value is the weight. What is the last element that we used in at this particular weight? Yes, and yeah, let's call it mem as in memory. So we here at this point we are making a decision of putting this current element X into our knapsack. right? And therefore, we are saying mem at this current weight, what is shit, I messed up in this part. Is because I'm using the current element and IT is the weight. Yes, okay. This is okay. This is okay. This is okay. We update last and we update, not update, but we put new values into the map. Mm-hmm. Yes. Yes. This is nice. I'm mostly thinking things in my head and I'm mostly not speaking. My bad for that. But I think I'm thinking about this in a right way. And memory, what do I put in the memory? I say at this particular weight, the element that I put in, put in is this plus go to x equals x, but x is a set. And okay, foundation is messed up. Shit. This has to be a multiset. Yeah, this has to be a multiset and don't even need this. I like literally don't need this. Don't need the possible weights, and that would be it for the main function. And here I can update this to be a multi-set. Okay. And I think this part is pretty good. And then this is good. But then how do I keep in memory? What things do I need to remember to reconstruct this solution? Yes, because I need to remove elements from A. There is one thing which is possible, and that is there is one thing which is possible, and that is to see what the maximum, not the maximum achievable. Ah, shit, no. Nope, this is not going to work. Shit, how can I mess this up? Shit, this is not going to work because if shit. No, this might. This might actually work because this might actually work. Okay, I thought this might not work because here in this example, I am finding out what the maximum number of people are, which is easy to put in a bag at a certain point. And let's remove the memory part. See out LSP, and this should return 2. This should return 2. And let's say we just remove a dot erase a dot begin, and after that we just erase the next element again. Go to X is somehow wrong because do we not get a iterator but the actual value? Okay, we do get an iterator. A is a multiset. What is the problem? Have int. It wants multiset int, and what I'm sending is also a multiset int and integer minus w is also an int. Invalid type argument of unary. This type have int. But then again, I'm getting errors. Okay, iterator plus. Since this is from a map, I have to take its second value and second and the same here. Dot second. Key I left at this point. Second and 1 2, that is okay. 1 2 is wrong. 1 not 1 2 but 2 1. Yeah, 2 1 2 1 2 1. Okay, okay. Yeah, this thing is correct. So after I come out of this loop, LSD is the max people I can have in a lift. Now, with this LSD, I need to find the maximum weight, which is lower than capital W, which LSD number of people could have. And what is the maximum? There is a brute force approach. Since I only have 20 people in the set, so 20 into 20 into 20, if there are like 5 people I'm choosing at a time, then 20, if I have 20 people, and 20 into 20 into 20 into 20. At max, let's say it is 10. So 20 into 10, 20 times, and I already am way above my limit. Yeah, so should not do that. Yeah, instead I should do some dynamic programming approach. Yeah, and now the goal is to find LSD number of people with max weight lower than W. If I can find that, then I will keep track of all of those people and I will remove them from the set. I want to share it with Primex. He is gone now. I don't know if I will ever get a chance to talk with him again. Yes, you can talk to him tomorrow. He comes here every day, and that is like very nice of him. Very nice of him. You can talk to him tomorrow. That would be nice. And I think this is easily solvable. Like if I even create a vector where I goes in one way and let's say I goes here and LST is increasing here using first I people. What is the maximum weight I could have, which is lower than W? And among those I people, I am only using LST number of people. And yes, in this case, where these weights are 4861, 4861, and list I can use at maximum, let's say 0 people. And when I'm using 0, then answer would be 0 for all of them. And when I'm using 1, 2, and 3 people. Wait, shit. Is this the actual way to get to the answer? Okay, when I'm using one person and I only have one person, literally one person, then if I do use this person, wait, what do I get left? I need to have the maximum weight, yes. Uh, yeah, so the maximum weight would be 4 here, and the maximum weight here would be 8. Why would it be 8? So either I do not use this person, in which case answer would be 4. But if I do use this person, then the current weight would be 8 plus using one less person at this point, answer was 0. So 8 is maximum and 8 is where we go with, what we go with. And then here we see if we use this person with the weight of 6. If I do not use this person with the weight of 6, we get answer of 8. But if we do, then 6 plus 0, which is just, yeah, 8 is good. 8 is good enough. And then here, if I do not use the person, then answer is 8. But if I do use this guy, then the answer will be 1. But I won't, so answer is 8. Again, and shit. This thing, the maximum number of columns this can have is 20. And also the maximum number of rows it can have is also 20. So to fill this once, we will take 20 into 20. 400. And let's say at 2. If I do use 4, I need to find the best value when I was using one less element, when I only had the choice of using all of these, and the answer would depend on something like something which is here. Let's say here every value is equal to 0. Yeah, so 0 plus 4, 4 would be the answer here. And when I'm using two elements, if I do use this 8th, eighth element, I will get 8 plus the best value here, which is 4. So I cannot get, I cannot use this eighth element. No, but I do know shit, I cannot even go to this place. At this place, answer is going to be -1 because it is not valid, because I need to use two people, but I only have one person here. So this is invalid, this is invalid, and this is invalid. So here, but if I do not, so I see, can I use this eighth element? No, I cannot use this eighth element. So, and the value that will propagate here is going to be -1. And then I ask myself, can I use the sixth element? If I do use this, but the thing is, I can add, this thing is -1. I can use 6, not with the best value till this point, but with this thing, 4, and get a sum of 10. It's like n cube. Uh-huh. And whenever I update a value, I shit, okay, this thing is not making a lot of sense. This thing is literally not making a lot of sense. But okay, let's stick with this. Nah, maybe okay, I will come back to this problem later. But I think I'll be able to solve this. Yep, no big deal. I will be able to solve this. Yep, it will be cool. Let's see some other problem for the time. Counting numbers, maybe. Your task is to count the number of integers between a and b where no two adjacent digits are same. Shit, okay. If no two adjacent digits are same, so we cannot count 1 1 2 2 or 3 3 4 4 5 5 6 6 7 7 8 8, and also 1 2 2. Okay, this feels like inclusion, exclusion. I think the answer depends on the number of digits specifically, and not on what these are. K here, if A is 1 2 3 and B is, let's write a function which takes in some number x, and it will return the answer for the range 0 to x inclusive. And then we can at the end just do f of b minus f of a. That would be our answer. This one, no, this one, counting numbers. And 1 and 2. integers between a and b and not a and b, okay, between a and b. So we do not want to count this number b, so we will just -1 if b is one of the numbers that we do not want. Yes. Okay, so for x, we will the answer would depend on specifically the number of digits that are in x. Let's say x has 2 digits, so we will go from 0 to 99, right? We go from 0 to 99, and we will first of all see in this range, in this interval for the first, and let's say x is equal to not 2 but 4. Okay, let's go to just 2 for simplicity. 2, and yeah, so these are the places. Ones place, no, ones place and tens, zeros place and tens place. Yes, zeros place and tens place. So first we will make sure we are counting the numbers which do not have these things, and let's say x is specifically speaking 79, just any random number. And we will first of all find the answer for all the 2-digit numbers, and we will then fine tune for x. Yes, so let's first of all make sure that this range is covered. These two are not the same, and how many are going to be same? When going from 0 to 99, there is going to be 11, then 22, then 33, then 44, then 55, 66 until 99. There are 9 instances for the first two numbers, 2 digits. And then for the next 2 digits, there are again going to be 99 instances. But the interval, here the interval is 10, 10. This is the interval. This is the interval. The first place that there is a matching pair -0, which we can say if this thing is 0th indexed and this thing is 1 indexed, then this interval is going to be, this thing is 10 indexed, 10 power 1 plus 10 power 0, that is going to be the interval, and we can iterate I from 0 till size of x minus 1. And we can use inclusion exclusion in that range, and we will not, yeah. And for the last I, we will have to fine tune our answer. Okay, we can do this. We can do this easily, and not easily, but yes, I think we can do this. And I thought the same for the last question, but I think we can genuinely do this. And before we do this, I would like to go to the washroom, and I will be right back. something like that. And yes, cool. But I feel like the logic is correct, but I feel like this might not work because this is a dynamic programming question and I am using inclusion exclusion principle, but that should not be a problem. I mean, if this was solvable by inclusion exclusion also, but the goal is to solve this with dynamic programming. Let's first try to solve this with inclusion exclusion. Okay. So fx is something that we have to calculate. Yes, and can we define this recursively actually? And fx returns an answer for range x, answer for range inclusive 0 to x inclusive. This is what fx returns. And can we define fx in some better way, in some recursive way? So we know that fx equals answer for range 0 to x. What would be the subproblem on which this thing depends on? The number of digits is the only thing. So something like fx divided by 10. If we actually go for some example, if I have answer for no, not if I want to find the answer for 293. First, I need answer for this thing. What is the answer for this range? And the answer we can like brute force here. We will have pairs which are equal 1 1 2 2 3 3 till the last pair that we have to exclude is going to be 8 8, and in total we have from 0 to 93 numbers. Zero, let's not include 0. So if we do not include 0, yes, 0 is not included in the answer. So this is what we have, and in total we will have 8 numbers that are same. Therefore answer for 93 is going to be 93 minus 8 85. We have 85, and given that, can we find answer for 293? We want to find f 293, and what we have is f 93, and I think there is a way we can do this. Answer for 93 is 85. F 93, whatever the number is, multiplied by how many intervals? So this first number can range for some amount. This first number can be 0, it can be 1, it can be 2, right? That is the maximum value it can have. And this number 93 It is going to be 93, 93, 93, and then 93. This is not going to be 0 because that just makes it a two value number, so not 0. It can be 1. And uh, here, when this number is equal to 1, when this number is equal to 1, how many out of these 85 valid options, how many? Okay, and we also need the place value, for this number, 10, 100, if it is 100. What is the interval over which this 9 is, this place is updating, that is 10. And when this first number is 1, the maximum value that this second number can have is 9. So at some point, this 9 is going to be equal to 2. And therefore, I want to remove 10 from this answer and add it. But there is also going, but there is also going to be a time when we add 2 to 2, and I would have reduced for this and for this. This is inclusion exclusion. So I want to add 1 for this. I thought we had this. Okay, I guess I just need to take a walk. Yes, I think for today, this is going to be the end. And I feel like I just need to take a walk for the day. And that would be it for today. And thank you for being here. Bye.